Now let's look at this different type of solving any integration question, which is known as the substitution. So what we do here is we consider a portion of the function provided to us as some other variable such as u, and then we consider its differentiation multiplied next to it. So here let's say we are assuming u is equal to gx. So my du by dx would simply become g dash x, or I can write my du, or this would simply imply that my du would be equals to g dash x into dx. So let's say if I have a function where I have f of gx into g dash x dx, and now if I consider my gx to be u, so I would have f of u, and my g dash x into dx, this would turn into du. So now, of course, my function has become quite simpler for me to solve. I can simply integrate it using any of the standard forms that I learned, and then at the end I can substitute u with the gx that I had assumed it to be. Now, what is the general steps for you to do substitution method? First, it is for you to choose the appropriate function to substitute. So I'll write it down. Choose the most appropriate function. Choose the most appropriate function to substitute. Then find out your dx. Find dx and then solve the integration. So this is the general way of substitution, how we can use it in our very complex integration questions. Now this substitution would work on any type of substitution. Let's say if I have integration f dash x upon f of x dx, still I can assume my f of x to be t, and my f dash x dx would become my dt. Let's say if I have integration f of f to the power nx, and I have f dash x multiplied next to it, still I can assume my f of x to be t. So I would have basically integration of t to the power n, and this would become dt. So this is how you can solve your questions which are related to substitution. Keep this thing in mind. So let's look at a question to see how we can solve it. Now in this question, they've given us a function which we need to integrate. So they've given us cos theta d theta 5 plus 7 sin theta minus 2 cos square theta. Now if you look at this carefully, I have a cos theta d theta in the numerator. So if you remember, cos theta is basically the differentiation of sin theta. And in my denominator, can I convert all my terms in the form of sin theta? Yes, I can. Cos square theta can be written as 1 minus sin square theta. And based on that, I can assume my sin theta to be t. Then my integration would become quite simpler, it seems. So let me first substitute my cos square theta as 1 minus sin square theta. So this would become integration of cos theta d theta upon 5 plus 7 sin theta minus, here I would have 2 and plus 2 sin square theta. So now what I'll do is I'll assume sin theta to be t. So I would have cos theta d theta is equals to dt. So this would, so my integration would now transform into, this would become dt on top, and below I would have 2t square plus 7t plus 3. So this is the integration that I have. Now I can simplify this integration into a perfect square format. And now the general way of solving such type of inequality, such type of integration where you have a quadratic in the denominator, is first you create a perfect square. Then you would have, of course, integration of 1 upon x minus a square, let's say, or x plus a square whole square plus some other constant b square. So there is a standard formula to solve it, which is of ln. So I'm going to directly write down the formula for it. Later on in this chapter only, when we study classic integrals, there you will see how we come to that formula and how we can also prove that formula using some other substitution methods as well. So from here, what I'll do is I'll try to convert this into a perfect square format. So this would become dt by, so I can write this one down as t plus, of course, my first motive would be to make the coefficient of t square as 1. So if I take 2 common, so I would have 7 by 2, I would have 3 by 2. So this would basically become 1 by 2 multiplied outside, and I would have t plus 7 by 4 whole square. And I would also have a 5 by 4 whole square subtracted outside. So if you look at this carefully, I would have t square plus uh, from here I would have 7 by 2t, which can be removed if I multiply this 2 inside, and then I would have a 49 by 16. So 49 by 16 once subtracted by 25 by 16 would simply give me 3 upon multiplying by 2 as well. So it would become the exact quadratic equation that we have. Now, there is a direct way of solving this type of integration. Now, right now, I'm going to write it down directly for you. Later on in this chapter, we will learn how we can solve such type of integrations as well. So this is written down as 1 by 2 ln of, this would become t plus half upon t plus 3. And of course, I'm going to have a constant also multiplied, added outside. So this is what my integration is coming out to be. Also, let's say if you are not comfortable with directly writing down such formulas, what you can simply do in such type of questions is that you can, now let's say you have 1 upon x plus a whole square minus b square. So of course, you know that there is going to be an ln. So what we'll do is we'll try to create in the numerator such type of variables so that we can separate it out in two different terms, and then they can cancel it out each other, and then we would get ln. So that is the basic way of doing this. Again, I'm repeating this again. Later on, we will study how we can solve this type of integration. Just for this question, just for the understanding of substitution, I'm writing it down directly. So now, once I've gotten the integration, what I'll do is I'll substitute t with my sine theta, what I had assumed it to be. So this would become 2 sine theta plus 1 upon 2 sine theta plus 6, and I would have a plus c outside as well. So this is what my equation is coming out to be. Now what have they told us? That this entire function is equals to a ln p, which is a function of theta, plus c. So we know what is our c, we know our ln, so our a becomes equals to half, and this function inside ln, this is basically our b theta. So we've gotten our function as well. Now what have they asked us? They've asked us to find out the value of b theta upon a. So let us just find it out. So our b theta by a would be equal to, if I divide anything by half, it would become 2 times of, here I would have 2 sine theta plus 1, and here I would have sine theta plus 3 into 2 multiplied outside. I've taken the 2 common so that this 2 and this 2 would get cancelled out, and I would be left with 2 sine theta plus 1 upon sine theta plus 3. So this becomes my answer. Sorry. Upon integration, we would get a 1 by 5 here. So basically, after integration, this 1 by 2 would be cancelled out from each other, and then we would have a 1 by 5 common left out. So this would become 1 by 5 here as well. And here also, I would have a 5 here. This would remain 2 as it is. Here we would have, here I would have sine theta plus 3 only, because of course that 2 can be taken common outside, it can be cancelled. So that is why I'm writing it down directly. So from here we would get 2 sine theta plus 1 and a 5 multiplied here. So this becomes my answer. So I hope you must have gotten how we can simply substitute any value that we have based on the differentiation which is present next to the d theta or the dx variable present to us. Let's look at a few more questions. Of course, as I mentioned earlier, This chapter is mostly about practicing. So let's look at one more question. Integration of sec square x into cot to the power 4 by 3x. Now we know that sec square x, it is the differentiation of tan x. So let me try and convert this cot 4x, 4 by 3x into tan x. So I can write this down as integration of sec square x upon tan to the power 4 by 3x dx. So from here, I'll assume my tan x to be t. If my tan x is t, now if I differentiate it, it would become sec square x dx is equals to dt. So from here, I would get dt on top, and below I would have t to the power 4 by 3. Now if I simply integrate this, this would become t to the power minus 4 by 3 plus 1 upon minus 4 by 3 plus 1. And I would have a constant of integration multiplied next to it. So here I would have t to the power minus 1 by 3 upon minus 1 by 3 plus c. So what is my t here that I had assumed it to be? So this would become minus 3 times of tan to the power minus 1 by 3 x plus c. This is my answer. So I hope you must understand how you can simply replace and substitute your values. Let's look at one more question on substitution. Let's say you have this question now. Of course, I can see that on the top in my numerator, I have a bit of the differentiation of my denominator. So it becomes 4x cube. I have x cube, and for x, I have 1. However, the sign is different, and what else is different is the coefficient. So what I'll do is I'll have to try to make the coefficient same. So what I'll do is I'll take x square common from the numerator as well as denominator. So I would have x square taken common. So this would become 2x minus 1 by x square. And below, I'm going to have x square taken common. Here I would have x square plus 1 by x dx. So now if I look at this, x square and x square are going to get cancelled out. X square, its differentiation is 2x, which is present above. 1 upon x, its differentiation is minus 1 by x square. It is present above. So from here, I can assume my x square plus 1 by x to be t. So this would become 2x minus 1 upon x square dx. This would become dt. So from here, upon replacing the values, this would become dt by t. And simply, how can I write it down? This would become ln of t plus c. Now, if I replace the value of t, I had assumed it to be x square plus 1 by x plus c. So I get this as my answer. Now again, very simple integration. The thing is you need to identify how you can substitute your values to find out the differentiation and then replace them. Let's look at one more question. I of x, they have given us an integration function, and they've told us that x is greater than 0 if limit x tending to infinity I of x is 0. So basically, they've given us this information to find out the value of c, which is our constant of integration. Upon applying the value of x as infinity, we would get our entire value to be 0. So that means from there, we would be able to find out what our c is. And then we would have our final function with us. Then we can simply put 1 and find out our answer. So first and foremost, our way is to find out the integration of this function provided. So in this function, what I'll assume is, I'll assume my 1 plus x e to the power x to be t. What would its differentiation become? It would become e to the power x plus x e to the power x dx is equals to dt. Here, what I can say is 1 plus x dx, which is in the numerator. This would be equal to dt by e to the power x. Now let me replace these values in my integration. So I would have my I as integration of dt upon x e to the power x, and here I would have a t multiplied. Now x e to the power x. If I have 1 plus x e to the power x as t, that means from here what I can say is that x e to the power x would be t minus 1. So simply I can replace that value here, right? So it would become integration of dt upon t minus 1 into t. Now again, I'll try to create my numerator in such a way so that I can separate it out in two different terms. And once they've been separated out in two different terms, the fundamental terms would simply cancel out amongst each other, and my integration would become quite simple. So what I'll do is I'll write this down as t minus of t minus 1. So if you look at this, this would become basically, sorry, here we had a square. So this is t square basically. So this would become t minus t plus 1. So we would have just 1 above, right? So here I have t minus 1 into t square. Now let me separate out the terms. So I would have integration of 1 upon t into t minus 1, and minus of, I would have 1 upon t square. Now I have dt in both these sides. Of course, I'm not writing it down again.